So subtopic 6.1, circular motion. This is a formula for the tangential velocity. So if you've got a wheel spinning, right, and you know the radius of that wheel, and you know the angular velocity, so this is our angular velocity. So this would be meters per second, right? This angular velocity is going to be in radians per second, right? Also known as, and this is our radius. It is the only it's the only tangential relationship we have. The other ones are S is theta r, and of course linear acceleration is alpha r. Okay, this is the only one that's actually in the data packet, but they're all true. Okay, so if you know the angular velocity, if this is going 6.28 radians per second, and you multiply by the radius, you'll get the linear velocity at the edge of the wheel. And then this is centripetal acceleration. The r is, of course, the radius, right? That's our radius of our circle, right? V is the tangential velocity, same thing, right? These guys are the same. And then t is the period, the time to go around once. And that's our velocity, right? And then this just follows from F equals ma, right? So therefore, F equals mv squared over r, because a is v squared over r, right? They could have told you that it's also m4 pi, whoops. They could have said m4 pi squared r over t squared if they wanted to make it helpful, right? Because it's like here's an acceleration, there's an acceleration. But instead they say that it's m omega squared r, which of course means that omega squared r must also be a centripetal acceleration, right? So what this looks like, this should be what, omega squared r, right? And then this should be m4 pi squared r over t squared if they wanted to be helpful in parallel. And you'd switch these back and forth so they'd be, anyway, you know what I'm saying. Okay? All right.